Rational numbers are numbers that can be expressed as a ratio of integers, or what is the same thing as a fraction that only contains integers in the numerator and integers in the denominator. Let's look at some more examples of rational numbers. In a previous video, we talked about the integers and what are the subset of numbers that compose the integers. Now we're going to see that all of the integers belong to an even bigger set of numbers called the rational numbers. As we said before, rational numbers can be expressed as a fraction containing only integers in the numerator and in the denominator. So why do we say that all integers are also rational numbers? Well, because you can express every integer as that integer, any one you choose, divided by 1. Since divided by 1 doesn't change the value of the number, and both any integer, and 1 are both integers, well, you have a fraction that is composed only of integers. Therefore, any integer divided by 1 is a rational number. Now let's look at the exact decimals. Exact decimals are decimal numbers that do not continue infinitely after the decimal point, that do not contain an infinite amount of digits after the decimal points. Some of the more simple fractions are exact decimals. For example, 1/2 can be expressed as 0.5, 1/4 as 0.25, 1/5 as 0.2, and 1/8 as 0.125. Now if you look at 1 divided by 1024, it has a lot of decimal numbers. It has a lot of digits after the decimal point. It actually has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits after the decimal point. But the important thing here is that there are no more digits after the last 5. Since it ends there, 1 divided by 1024 is an exact decimal, and since 1 and 1024 are both integers, 1 divided by 1024 is a rational number. As a matter of fact, all exact decimals are rational numbers because they can be expressed as a ratio of integers. Now, I talked about simple fraction, but I did not mention 1 divided by 3, 1 divided by 6, and 1 divided by 7. What happens here? If you divide 1 by 3, you see 0.3333, an infinite amount of 3's after the decimal point. In 1 divided by 6, you see the 1 after the decimal point. It does not repeat, but then you have the 6 repeating infinitely. And in 1 divided by 7, we see some strange pattern there. 142,857, then again 142,857, and again 142,857. And if you could expand that, you will see that those 6 digits, 142,857, repeat infinitely after the decimal point. Well, it's no surprise that these decimal numbers are called repeating or recurring decimals. They repeat infinitely after the decimal point, be it one number or a combination or set of numbers or digits. Sometimes it is convenient, or you just need to express them as a decimal number. So you can write 1/3 instead of 0.333333. You can write 0.3 with a line on top of the 3. And that is saying that the number 3, that the digit 3 repeats infinitely after the decimal point. Now in 1/6, you can write it like this, 0.1 and then the 6 with the line over it. But be very careful. If you write the line also over the 1, what you're saying is that that number is 0.161616, infinitely repeating the 1 and the 6. So you must be very careful here and only put the line over the 6. That is why I don't like this notation very much, because people can be the pen can move a little more than you want to and have the line over the 1 without wanting to have the line over the 1 and cause a lot of confusion. Now in the case of 1 over 7, look at that. You can write it if you want as 0.142857, but that is very unusual, and I don't think most of the people, when they see that for the first time, will understand what you're trying to say. So in my opinion, it is much easier to write just 1 divided by 7, the fraction 1/7. There are less numbers, and it's much more precise to express that as 1 divided by 7 instead of using this big ugly thing here. Now all recurring decimals are also rational numbers. All recurring decimals, like in the case of 1 over 7, can be expressed as a ratio or a fraction composed only of integers. So, to recap here, any number that can be expressed as a fraction composed only of integers is a rational number. But be careful. Let's say, for example, x divided by y is a rational number. X can be any integer, and y can be any integer except 0. You cannot divide by 0. So, rational numbers are numbers that can be expressed as a ratio or as a fraction of integers, but the denominator can be any integer except 0. Some examples of rational numbers, as we said before, are the integers, which can be divided by 1 and expressed as rational numbers. The exact decimal numbers are all rational numbers. The recurring decimal numbers, which repeat forever but in a predictable pattern after the decimal point, those are rational numbers. And something that I forgot to tell you, when you have a decimal number that has a part that repeats forever and one that is exact, that is called a mixed decimal number. For example, in the case of 1 divided by 12, in this case 0.08 would be the exact component of the decimal part of the number, and the 3 will be the recurring or repeating part of the decimal number. So this can also be expressed as a mixed decimal number. Thank you for watching all the way to the end. If you found this useful, please subscribe, tell a friend, and don't forget to check some of my other videos and the playlist. Once again, thank you, and see you on the next video.